Hi and welcome. I'm trying to learn planetology or planetary science. Today, Jupiter, and after we've done it, we're going to do leg injury prevention training. And if you participate in the leg injury prevention training, then it's valid your own risk. Now I have here this little article written about Jupiter and Saturn. We did it in space science, but now we're going to focus on Jupiter. So this is now planetology, and we're going to go over and try to look what we have said about Jupiter. In the solar nebula, billions of years ago, there was a strong temperature gradient. Close to the newly forming sun, where it was hottest, icy substances were unable to condense. That means to turn from gas into liquid or solid. But substances such as iron and rock were readily able to do so. Okay, condense. Other things than just water can condense, I think, I read that from it. Also, rocks can condense, and it would make sense. I think it's all over known that metal can be melted at around 1000 degrees when it is liquid. Now, could someone say, well, it wouldn't be from gas into liquid, so not condense. But it could be that it would be interesting. Was now the rocky material actually liquid or even vaporized, if it is possible? Another question, is it possible to make rock vaporized? And that was what saying, oh, okay. Close to the newly forming sun, where it was hottest, icy substances were unable to condense, while substances such as iron and rock were readily able to do so. So was iron and rock liquid? Or even gas? Roughly 5 times further from the sun than the present orbit of the Earth, at the so-called snow line, the temperature dropped to a point where ices could condense. Okay, 5 times away from the sun, where water could condense. And the Earth is away from 150 million kilometers, 1 astronomical unit. 150 million kilometers. So around 750,000, 800 million kilometers, 800 million kilometers from the sun where it was cold enough that icy things could get solid. Icy substances. Roughly 5 times further from the sun than the present orbit of the Earth, at the so-called snow line at around 800 million kilometers. The temperature dropped to a point where ices could condense. Icy particles are much thicker than the rocky and metallic ones that condensed closer to the sun. So the snow line planetesimals quickly grew to planet-sized dimensions, because icy particles are thicker, because the particle cells are thicker. In just 100,000 years or so, an icy kernel 15 times more massive than the Earth appeared. Jupiter was forming. Now we have Jupiter. Okay, at the beginning of the forming of a solar system, what happened to the icy substances close to the sun? The icy substances more than 800 million kilometers away from the sun, where it was cold enough, it is so-called snow line, could condense, and they got sticky together. They stick them together, and over the course of 100,000 years, many enough stick together that they formed an icy kernel of already now 15 times more massive Jupiter than Earth it is. By far the most abundant elements in the solar nebula were the gases hydrogen and helium, both lightweight, fast-moving and difficult for gravity to snare. The icy, newly forming Jupiter grew so massive that its powerful gravity was able to suck in even these lightweight materials. For several 100,000 years, Jupiter gorged itself vacuum gases from its environment, and none were left. The end result was a massive hydrogen and helium ball, 11 times larger than the modern Earth, with a solid core of rock and ice, a gas giant. Twice as far from the sun, Another gas giant formed Saturn. Being further out, where the density of raw materials was much less, Saturn could not grow to the dimensions of its larger cousin. Still, it is a true giant, a respectable 9 times larger than the Earth. Gas giants are the largest planets we know of. Jupiter and Saturn are the only two in our solar system, but elsewhere in space, orbiting other stars, these planets are very common indeed. Jupiter is the quintessential gas giant planet. It has no solid surface, just a vast, colorful envelope of super-compressed hydrogen and helium surrounding a solid core of rock and ice about the size of the Earth. Okay, they have also a solar nebula. I don't know if a solar nebula is the name for the solar system in the beginning. When the solar system was forming a few billion years ago, it was hot, close to the sun, but 800 million kilometers away from the sun, which is, is it not? It must be 5 times. But 800 million kilometers away from the sun, which is 5 times the distance as the Earth is away from the sun, there it was not so warm, there it was behind the so-called snow line, and there the icy substances, so we really call them like that, icy, it sounds like ice, so solid. The icy substances froze and they got ice. They condensed. And they started to stick together. And over the course of 100,000 years, they have sticked enough together to become an icy kernel, an icy piece, with 11 times, 15 times, yeah, we have 11. That is the end result. It was a massive hydrogen ball, 11 times larger, 15 times more massive, and 15 times as massive as the Earth icy kernel that was the beginning of Jupiter. And now, there's a lot of hydrogen and helium. We also expressed by far the most abundant elements in the solar nebula were the gases hydrogen and helium. And there was a lot of hydrogen and helium in the solar system, the solar nebula. And they are very lightweight, and it is a lot of gravity necessary to pull hydrogen and helium towards it. I don't get the part of hydrogen. It is hydrogen and oxygen. Two hydrogen and one oxygen. H2O2. Wasn't it 1 over 1? Whatever. It's hydrogen and oxygen. This is water. No, why is no? I don't get the concept of hydrogen. Okay, there was hydrogen and helium, and it's hard to grasp hydrogen and helium because they are very lightweight gases. But now this icy kernel was 11 times as massive as the Earth is, so it has a lot of gravity and was able to pull in this helium and hydrogen. And it formed then over the coming hundreds of thousands of years. Several 100,000 years, Jupiter gorged itself vacuum gases from its environment and gorged all from its environment, all the helium and hydrogen gases into it, and forming an 11 times larger ball. I'm going to call it. Yes, they did it also. A massive hydrogen and helium ball, 11 times larger than the Earth is. That is Jupiter. It has in the inside a massive kernel, which was already, we don't know how this is now, how massive, which was already at the beginning of getting this, of sticking together. At the beginning of the forming of Jupiter, 15 times as massive as Earth, and it has the size of the Earth, and the whole thing with all the gases now pulled in around it together is now 11 times as massive as big as the Earth. That's Jupiter. It's a gas giant. Now it's Jupiter. Now I said it all. We could have said it in our presentation, but we don't have time. That means if you were here for planetary science, then you come directly to the next part of planetology, where we will try to say what I just said in one presentation, down where we have the information in that way as I said just then in the video. So if you're here for planetology, planetary science, go to the next part of planetary science or planetology. We will do now the leg injury prevention training. If you stay and participate in the leg injury prevention training, this will be harmless. Så bring the leg and the polymer footer. Take the other leg in and polymer footer. And now take the leg at the ankle, straight back, and point with the knee down to the floor. And change the other leg. Take it at the ankle, straight back, point with the knee down to the floor. And now to the next exercise. We are bringing one leg up, the breathing in, pine pilgrim, and out to the side. And in. And in the middle, down. Now again up. It's just one oxygen, it's 2 hydrogen, 1 oxygen, H2. Okay. Out to the side. And again in the middle, and down. And now again with that leg, I'm going to do the other one. Again. Onto the side. Breathing in. Out in the middle, and down. And the next exercise, we're going to skip a few. That means we're going to do a stem. Leg up, and down. Up, down. Up, and down. And now with the other one, up, and down. And we're going to skip more. That means we're coming to the end. We didn't do much, so we don't need to do stretching. I got a full with my shin bone. So that means I'm injured and I have to stop it now. I thank you very much. It was a short leg intervention landing. I thank you very much and next time.